let us turn our attention to page 79, and we're looking at the bottom part. We're going to be looking at expressing one quantity as percentages of another. We have two examples here. We'll work through those two examples, but let us take note of our rule. The quantity that comes after of must be used as the denominator. Always use the same unit for both quantities, then multiply by 100. We're looking at example A. What percentage of $15 is 75 cents? Okay, so the 15 comes after of, so that will be our denominator. So we would have $15. Pay attention to this part of it. Okay, and our 75 comes after 75 cents. 75 cents comes after is, so it's our numerator. And to complete the problem, we'd multiply by 100 over 1. Now, part of our rule says that we need to make sure that both of them are the same unit. Okay, so both of our quantities here are not in the same units. We have 75 cents, and now we have here for denominator, which I said pay attention to earlier, $15. We can't solve the problem like this. We need to make both quantities the same unit, having the same unit. Now, it is easier in this case to change our $15 into cents. Okay, and how we would do that? If we have $15 and if $1 has 100 cents, we just multiply using our knowledge of powers of 10 and multiplication by powers of 10. We would simply add 2 zeros to our 15 and we have 1,500. So where we have $15, we would write 1,500 cents. Okay, so if we were to rewrite this, it would be 75 over 1,500 multiplied by 100 over 1. Some people are going to say, sir, why couldn't we have changed the cents to dollars? That would have given us a decimal number here, and it would have made it a bit more difficult to work it out. So we will convert our dollars to cents, and we will have a nice number that is easy to work with. Let's reduce as best as possible here. We could say this 0 could cancel this 0, and this 0 could cancel this 0. We would be left with what? 15, which is the same as saying 100 into 1,500 goes 15 times. It's the same thing. Now, using our knowledge of the rules of divisibility, we could say since 15 has in its ones place 5 and 75 also has 5, it therefore means that 5 could go into both of these numbers. So 5 could go into 15 3 times, and 5 could go into 75. Well, 5 could go into 7 1 time, leaving 2 as a remainder, and 5 could go into 25 5 times. Therefore, it means that 5 could go into 75 15 whole times. Can we reduce any further? Yes, we could. 3 could go into 3 1 whole time, and 3 could go into 15 5 whole times. To finish off now, we'd multiply our numerator by our numerator and our denominator by our denominator. 5 times 1 would have given us 5 here, and 1 times 1 will give us 1. This is the same as saying how many times can 1 go into 5? It could go in there 5 times. And since it is that we're finding what? Percentage, our answer should be in percentage. Alright? So, to conclude, $15. What percentage of $15 is 75 cents? 75 cents would have been 5% of $15. Please take time. Remember that our denominator comes after of, or numerator comes after is, and our units must be the same. Let's turn our attention to example B. What percentage of one day is 18 hours? Now, establishing our numerator and our denominator, 18 hours comes after is, and it will be our numerator. We have one day coming after of, so that will be our denominator as expressed by the rule. Now, we have to make our quantities the same unit, and here we have different um, units representing the numerator and denominator. We have 18 hours and 1 day, so we need to make them the same. And we could do that by converting the 1 day into hours. And 24 hours make 1 day, or 1 day is equal to 24 hours. So we'll have 18 for our numerator, and our 1 day, our denominator, we will write instead 24 hours. So here we have our 18 over 24 multiplied by 100 over 1. So using my divisibility rules, I could use 2, because if a number has in its ones digit 0, 2, 4, 6, or 8, then I can divide by 2. So 2 could go into 24 12 times, 2 12s 24, and 2 could go into 18 9 times 2 9s 18. I could now use 3. If the sum of the digits of the number is divisible by 3, so we could use 3 because the sum of these digits is 3, and that's divisible by 3, and 9 is also divisible by 3. So 3 into 9 would go 3 times. 3 3 is 9, and 3 into 12 would go 4 times. We could rewrite this so it's easier to see as 3 over 4 multiplied by 100. What's 3/4 of 100? That's 75%. By now we should be able to establish that a quarter of 100 is 25, a half of 100 is 50, and 3/4 of 100 is 75%. However, let's still solve this for those who are not aware. 4 could go into 4 one time, and 4 could go into 125 times. When we multiply 25 by 3, we get 75. 25 by 3, 3 5s 15, carry 1, 3 2 6, and 1 7. That's how we end up with 75. We would have what? 75 over 1, which is the same as 75. And since we are finding percentages, our answer needs to be in percentage. So, to review example B, what percentage of one day is 18 hours? It would be 75%. So 18 hours of one day is 75% of a day. So exercise 7, page 18, number 1. What percentage of 36 is 9? So the thing that comes after of 36, that has to be the denominator, and whatever comes after is the numerator. So we have 9 over 36. Let's use the smallest numbers that we can. We could say 3. 3 goes into 9 3 times, and 3 goes into 36 12 times. We could then say 3 could go into 3 one time, and 3 could go into 12 4 times. Now we have 1 over 4, which is the same as a quarter. A quarter of 100 would be 25. Our answer is in percentage. We could also say, if we are better with working with larger numbers, we could say 9 into itself one time and 9 into 36 4 times, still giving us 25%. Number 2, what percentage of 80 cents is 24 cents? So 80 cents comes after the of, so it's our denominator, and after the is we have 24 cents. Let's use let's put this over 1, and we could say this 0 will cancel this 0. We could now use 2. We could say 2 could go into 8 4 times, and 2 could go into 10 5 times. We could use 2 again. We could say 2 into 4 2 times, and 2 into 24 goes 12 times. We could say again 2 into 2 goes 1 time, and 2 into 12 goes 6 times. Multiply across. 6 times 5 would give us 30. 1 times 1 would give us 1, which is the same as 30. Our answer is in percentage. So for number 2, our answer should be 30%. Number 4. We go to number 4. So what percentage of 1 hour is 24 minutes? Remember that we need to keep our units the same. So after the of, we have 1 hour. Now if we were to write 1 here and put 24 minutes at the top, we would not be correct. So our 1 hour is the same as 60 minutes, and after the is, the quantity after the is will be our numerator. So now let's reduce as best as possible. We could say 0 cancel 0. We could say 2 into 6 will go 3 times, and 2 into 10 will go 5 times. We could now say 3 into 3 would go 1 time, and 3/8 would make 24. We multiply across. 8 times 5 would give us 40 over, multiplying our denominators, 40 over 1. Our answer in percentage is 40%. Let's look at exercise 8 on page 80, and we are going to look at number 1. Mary saved $25 out of $200. What percentage did she A. save and B. spend? Again, our 25 comes first, and the number following the of is 200. So our denominator is what? 200. So we will reduce as best as possible. We could say this 0 here will cancel this 0, and this 0 will cancel this 0. Now we are left with multiplying across. 25 times 1 would give us 25 over 2. 2 times 1, 2. So our answer will be whatever 25 is divided by 2. Let's put that aside here. We could say 2 into 2 goes 1 time, and 2 into 2 1 time. We now could say 2 into 5 will go 2 times, because 2 2s will make 4. We have a remainder of 1. So we'll add a decimal point, and we'll add a 0. And we say 2 into 10 would go 5 times. Our answer 12.5. So for the saved section, our answer would be 12.5, or 12.5%. Now logically, to find the amount that was spent, all we need to do is to take away from a 100 representing the whole, the amount that was spent. Because remember, we're going to have two sections here. We're going to have to make the complete amount, the 200. He would spend some and he would save some. So all we need to do is find the difference. So that will be 100, and we'll take 12.5 from the 100. Okay, that's what we had set here. Don't have enough space there. Now, to complete this, we're going to need what? We're going to need a placeholder because we have one place of decimal there. Now we will subtract. Can we take 5 things from 0? No. We'll need to move to the next column to borrow. There's nothing there, so we'll move to the next column. And there's nothing there, so we'll take from the 1. We'll put that here, leaving us with 9 when we take 1 from it. Put that 1 there, leaving us with 9 there, and carrying that 1 to where we need it, making 10 here. 5 from 10 now, that could work, and we are left with 5. We'll put our decimal point under our decimal point. We now go to our ones or units column, and 2 from 9 would leave 7. 1 from 9 would leave 8. Our answer for this section spent would be 87.5%. So, to review, Mary spent $25 out of $200. What percentage did she save? She saved 12.5 or 12.5%. And what percentage did she spend? She spent 87.5% of the $200.